Okay, this is my gas laws project. The conversions we will be using is Celsius to Kelvins and Kelvins to Celsius. So to find Kelvins, to find Kelvins, you'll get the Celsius and add 273.15. And to find Celsius, you'll get the Kelvins and subtract 273.15. And the common, what's it called? Like the common measurements we'll be using is Kelvin, Celsius, atmospheres, torrs, liters, and grams. The first law is Boyle's law, which is also known as Marriott's law. Boyle's law is about the relation of compression and expansion of gas at a constant temperature. It was discovered by the French physicist Edmé Marriott in 1676. The equation of Boyle's law is P1 times V1 equals P2 times V2. P stands for pressure and V stands for volume. A real-life example of this is when you breathe. When you breathe in, the volume of your lungs expands, but the pressure weakens. When you breathe out, your lungs' volume decreases and its pressure increases. Here's my practice problems, and for this problem, I knew this was Boyle's law because it talks about pressure and volume. So first I multiplied it out and then I divided it out, and I got the gas. The volume of gas would be 474.78 milliliters of gas. Okay, and then here's my experiments. In this experiment, I said it was Charles' law for some reason, but I meant Boyle's law. So this is Charles' law, and like a way to show volume and pressure increasing is like blowing up a balloon. So just like, that's like the volume and the pressure increasing. So this is Charles' law. I don't know if those are really quiet, but for me they're really quiet. Okay, Charles' law. Charles' law was thought of by the French physicist J.A.C. Charles in 1787, but then was tried and proven by the chemist J. Louis Gay-Lussac. Charles' law states that if the pressure is constant, the volume with a fixed amount of gas is directly proportional to its absolute temperature. The equation of Charles' law is V1 over T1 equals V2 over T2. T stands for temperature and V stands for volume. The graphing will look like Y equals X. A real-life example of this would be when it's a cold day and you are playing with a ball. The ball would shrink a little because the temperature is colder. Here's my practice problems, and for the equation, I knew this one was Charles' law because it involves only volume and temperature. And I first multiplied it out, I found the kelvins, and then I multiplied it out, and the temperature needed will be 964.91 kelvins. And here's my experiment. My name is Calvin Leibel, and this is an example of Charles' law. I turned it off, but you evaporate the water into the balloon. My name is for that, what I did was I put water under a balloon and I heated it up in a bottle so the water would vaporize and blow the balloon up. And Avogadro's law. Avogadro's law was made by the professor Amedeo Avogadro in 1811. However, it was not accepted until 1958 when an Italian chemist named Stanislao Cannizzaro proved it. Avogadro's law states that when the volume in something changes, so does the amount of gas. The formula of Avogadro's law is V1 over N1 equals V2 over N2. V is volume and N is the amount of gas in moles. A real-life example of this is when a tire deflates. When the number of moles decrease, so does the volume. And this is my practice problems, and for the problem, I knew this one was Avogadro's law because it involves grams and pressure. And I can convert, first I converted the grams into moles, and I multiplied it out and found out that I need 2.74 moles. And then, so for the experiment, I don't know, it's like weird. It won't let me insert it, but here, let me try and go to it. It's this one. This is Avogadro's law, and a way of showing it is blowing up a balloon, and the moles increase with the volume. So, more, like, moles of carbon dioxide have gone in, and the volume increased. Okay, this is so I blew up a balloon, and I explained how the volume increased with the amount of carbon dioxide in the balloon. Okay. Gay-Lussac's law. Gay-Lussac is a French scientist who named the law after himself. Gay-Lussac's law states that the pressure is directly proportional to the temperature under a constant volume. Gay-Lussac's law formula is P1 over T1 is equal to P2 over T2, or P over T equals K. P is pressure and T is temperature. A real-life example of Gay-Lussac's law is a pressure cooker. When the heat in a pressure cooker rises, so does the pressure. And here's my practice problems. And for this one, I knew it was the problem was about Gay-Lussac's law because it involves pressure and temperature. And first I changed the Celsius to kelvins, and then I multiplied it out, and the new pressure needed would be 296.59 millim. I don't really know what that is. Okay, so yeah, I have two. Okay, so I have to go back. Okay, yeah, I accidentally clicked the wrong thing. Okay, here's part one of this. This is Gay-Lussac's law, and I'm going to put the green balloon in the freezer and compare the two after it's frozen. Okay, this is Gay-Lussac's. Here's part two. These are how the balloons look now. The green one is way noticeably smaller, and it's I don't know, it's see-through. I don't know if it was before. These are okay, so for that experiment, I put the green balloon in a freezer and the red balloon in out of a freezer, and the green balloon shrunk and the red balloon stayed the same. Okay, combined gas laws. The combined gas law is just a combination of Boyle's law, Charles' law, and Gay-Lussac's law. The formula for combined gas law is P1 times V1 over T1 equals P2 times V2 over T2. So pressure times volume over temperature. Combined gas law is the only thing constant. Is the amount of gas or volume. In the combined gas law. I don't know why I read. An example of combined gas law is a refrigerator. Here's my practice problems, and I knew this one was talking about combined gas law because it involved pressure, volume, and temperature. First, I converted Celsius to kelvins, and then I got X by itself and multiplied it out, and I found the volume would be 1,375,304 milliliters. Here's my experiment. This is combined gas law, and I'm putting the glass on top of the tea candle, and it's gonna rise up and in water, and it's gonna rise up until the candle goes out. Okay, so for that one, I put a candle under a glass and it made the water rise up. Okay, ideal gas law. Ideal gas law is a combination of Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. The ideal gas law formula is pressure times volume equals the number of moles times R times V. R is ideal gas constant, so like 0.081, and N is amount of substance. A real life example of ideal gas law is airbags in a car. Here's my practice problems, and for this one, I knew this one was ideal gas law because it involved like all of them, like moles, liters, temperature, and you're finding the pressure, and you'll like start with R. So I multiplied it out, and then I got the pressure of 1.902 atmospheres. And then, yeah, that's it.